for example 3, we see that it is, again, has a squared term, so it's quadratic, but then it also multiplies by another x, so that's cubic. So we anticipate a possible 3 answers for this problem. Because it's cubic or quadratic here where we have the squared, we will have to solve by factoring. And what we'll do is get everything to the left-hand side and then factor out the greatest common factor. So I'm going to take this and subtract it over here. So minus 2 cotangent of x equals 0. So here's what I have, bringing that over. I got everything to one side equals 0, and then I can factor. Factoring means looking for the greatest common factor, or the thing they have in common, and they both have a cotangent of x. So I'm going to factor out cotangent of x from each thing, and then what I have left is cosine squared of x and minus 2. When you factor, you set each factor equal to 0. That's just a factoring technique. So I'll set that equal to 0 and set that equal to 0, and I'll solve them separately. Here, cotangent of x equals 0. I'll just inverse cotangent both sides, so I get x equals inverse cotangent of 0. And cotangent is x over y. If you look here on the unit circle, x over y, 0 over 1 would be 0. We're looking right at pi over 2. Here, I'd have to solve for x, so I have to add 2 to both sides. And then to get rid of the squared, I'll square root both sides. So I'm looking for inverse cosine of plus or minus square root of 2. I'll inverse cosine both sides. And if you know about inverse cosine, we're looking at the top half of the circle and we're looking for square root of 2. None of the x values are square root of 2. And actually, if you take your calculator and type that in, it's undefined. It doesn't give you any answers because square root of 2 is out of the restricted range of cosine, so we won't find any answers there. So our only answer here would be pi over 2. We'll do example 4 last, and we will have to solve. I'll rewrite it here so it's bigger. 3 tangent of x over 2 plus 3 equals x. So first I'll get rid of the plus 3 by subtracting 3 from both sides. And then I'll divide by 3 to get rid of that 3. So I have tangent of x over 2 equals negative 1. I'd like to get rid of that divide by 2, but it's really tangent of that, x over 2, and it's trapped in parentheses with a tangent on the outside. So as far as like unpeeling all the layers and solving, I need to get rid of the tangent first. That will open up this x over 2, and then I can get rid of the divide by 2. So the first thing I'm going to have to do is inverse tangent in order to get rid of that tangent. I'm left with x over 2. Inverse tangent of negative 1, I look at my circle. Inverse tangents, I look on the right-hand side. And inverse tangent of negative 1 would be here, because this divided by this would be negative 1. So it would be negative pi over 4. Then I look here, and I need to solve for x. How to get rid of a divide by 2? The inverse would be times 2. So here I'd have negative 2 pi over 4, which reduces to negative pi over 2.